So we saw that different monetary policy rules, depending on which coefficients there was, lead to different dynamics. If central bank targeted or had a high coefficient for output gap, then this led to output gap stabilization with the cost of, for example, nominal wage inflation. So the question is, what is the optimal thing to do for central bank? To answer this question, we need to have objective. What is the objective of central bank? In this microfounded model, obvious objective is households' welfare, to maximize welfare or minimize welfare costs, deviations from first best. In earlier literature, the objective was typically to minimize output gap and inflation volatilities, and these volatilities had then some weights, which then proxied the policymakers' objective. But with these microfounded models, we can derive households' welfare function actually in terms of volatilities of inflation and output gap, and then study what kind of rule minimizes these welfare losses. And if we don't restrict the central bank to follow a simple rule, like we have done this far, we can actually compute the precise optimal interest rate setting policy. We will compare again sticky price economy to flexible price and wage economy, since there the allocations and the equilibrium is always optimal. And if we minimize gaps to this flexible price economy, the gaps between sticky and flexible price economy, then we are maximizing the household's welfare in the sticky price economy. So recall, what are the distortions in the model? First, there are steady state distortions, which arise from monopolistic competition on product markets, and then imperfect substitutability between labor types, which both create market power for in the product market, and then for unions in the labor market. And then there are nominal stickiness, which leads to distortions when there are the dynamics, when shocks hit the economy. First, their optimality conditions are distorted from the steady state values, so the markups vary. But then there are relative price and wage distortions, which we haven't seen yet, since they are based on volatilities of price and wage levels, and we haven't seen these affecting, since we have studied impulse responses based on first order approximations, and then stuff that is of second order doesn't show up there. So what is the origin of relative price distortions? Recall that the final consumption good that households consume is given by this aggregator function, where this final consumption good that goes into the utility function is aggregated from these intermediate goods. And there is sort of decreasing marginal utility here, so that if you have 20, for example, 20 Cs, 20 intermediate goods of different types, and there are 10 different types of these. Let's call them candies. So if we eat total 20 candies and 2 of each type, we get total bundle of this candy, aggregated candy, equaling 20. But then if we eat unequal amount of these different types, for example, 3 candies of 5 different types, and then 1 of each 5 rest 5 different types, we will get the sum will be less than 20. So when we eat or consume unequal amounts of intermediate goods, then we will require more intermediate inputs or candies to obtain the same level of utility from consumption or eating candies according when we have this aggregator function in the model. And now that we have sticky prices where only a fraction of firms are able to reset their prices on each period, what happens when there is inflation, when inflation deviates from its steady state value, which is 0, then prices will differ across firms, and then the ones that have lower prices will be selling more their products. And then this will result that there will more intermediate inputs are required for the same level of consumption than in the equilibrium where prices are the same. And this inefficiency is further increased if we assume decreasing marginal product of labor, because then the marginal productivities will differ, and there will be firms with a lower productivity than others when they are selling more. So the origin for this is that price level varies, and then also the cross-sectional price dispersion. The prices of each firms will differ from the aggregate price level and from other firms' prices. And we can derive a function for this approximation for this dispersion term as a function of variance of prices, of price level, aggregate price level. And when variance increases, this increases, and it means that for the same TFP and employment, there will be less output once we have price dispersion. So households need to work more, or the economy needs to work more to produce the same output. Of course, one can question how valid or relevant this is in reality, and it is a bit ad hoc feature, but it gives sort of a real cost of inflation to the model, and a reason for central bank to maintain price stability or inflation stability. The same holds for wages. So when wages vary, there will be dispersion of wages, and then unequal amount of labor is demanded for different labor types. And then again, more labor input is needed to generate the same output level as would needed without wage dispersion. All right. So the objective for optimal monetary policy will be the welfare of the representative household. And then this maximization is constrained by the equations that define competitive equilibrium. IS equation and then the price and wage Phillips curves. And the household's welfare we are going to measure as deviation from the utility of the flexible price and wage economy. And then to make this maximization problem to work, we need to have something else than a linear approximation to household's utility to find maximum. So we are going to have a second order approximation for these welfare losses, deviations from the flexible price and wage economy. And then we are also going to take into account these relative price and wage distortions, since they show up in the second order approximations. Now we will focus on stabilization policies. How can a central bank respond to fluctuations when there are shocks? And to do this, it is easier if we can get rid of steady state distortion. So we are going to implement a sort of a subsidy that will make steady state efficient. So recall that for optimality, it is that marginal rate of substitution between leisure and consumption equals marginal productivity of labor. But this won't hold in our sticky price economy with monopolistic competition, since due to market power, there is this markup term to the for firms' price setting condition at the steady state. So real wage equals marginal productivity of labor times markup. And then monopoly power of unions, due to imperfect substitutability between labor types, creates another markup term for labor supply condition. So marginal rate of substitution doesn't equal real wage, it equals real wage times this markup. And once we solve and get rid of real wage, we see these markups over or behind markups with marginal productivity of labor here. And then to make to get from this condition to here to the efficient condition, it is often done that it is assumed that there's a sort of an employment subsidy for firms, which is given by these substitutability parameters, these markups. And then the cost for firms are given by this tau times the wage bill they pay. And with this, we get a price setting condition where we have this subsidy. And given that subsidy is of this size, the subsidy and the markups will cancel out, and we are left with efficient condition. So once we have a correct tau, we have a efficient steady state in the economy. And this is just to make it easier to do our analysis regarding the optimal stabilization policies. Namely, to show that to obtain this sort of a second order approximation to welfare losses. If the steady state was inefficient, this wouldn't hold. So it is possible to derive second order approximation for household utility function, where we have consumption and labor as arguments. So after some algebra, one can get to approximation where we have output gap, price inflation, and wage inflation, and some coefficients determining how much these affect to welfare losses. The welfare losses arising from inflation, wage inflation, and price inflation variability tend to be quite high because of these coefficients. So it's typically that these coefficients are 20 times larger, for example, than the coefficient for output gap. So new Keynesian model supports, in a sense, price and wage stability due to its micro foundations. In the earlier literature, it was typical to have 0.5 and 0.5 here, so that output gap stabilization had more weight. All right, this was the welfare losses for whole utility. So it's a summation, infinite summation, again, discounted summation. And then the periodic utility loss is given by this function here. So with these loss functions, we are able to study which monetary policy is optimal. So we can compare different rules and see which give smallest loss function. This will be part of the problem set, and then the model will be the flexible wage model, so that there won't be sticky wages and wage inflation term in the Taylor rule. Typically, the interest is in finding easily implementable rule where there isn't, for example, output gap, since observing it in real time is difficult and it's replaced with some other variables, for example, unemployment. Then just comparing this rule, another possibility is to derive exactly optimal monetary policy rule as an optimization problem, where we have a Lagrangian again. This compares simple rules. So we have a first strict rules here, where there's a really high coefficient, for example, for price inflation, and it keeps prices constant, so that inflation doesn't, price inflation doesn't move anywhere as there is a TFP shock. And similarly to wage inflation and this is for output gap stabilization. Okay, then and this is optimal policy, which we will study after this slide, which shows the optimal that can be achieved. And we can, and then flexible rules are rules where we have 0.5 coefficient for each price or wage or both inflation rates. So if we first of all, with these strict rules, we get more close to optimal policy, although with price stability doesn't seem to be working so well. And this is when nominal wages are more stickier than prices. Then if prices are stickier than wages, what we see is that, again, strict rules are working better. And then if we have really flexible prices and sticky wages, still it seems that these strict rules are better than flexible rules. And what brings the economy closest to optimal rule seems to be this strict rule, which is named as composite, but I think it is strict rule for output gap. There must be a typo in this table, which stabilizes output gap fully. This seems to be working almost as well as the optimal policy. Or it can be that when both price and wage inflation are stabilized, then no, it cannot be. It has to be. There has to be a typo in this. Yes. Okay. So this was to compare different simple rules. Then let's see how is it to compute the optimal monetary policy. There will be two different policies for this discretion and commitment. And let's start with, so that we have flexible wages, and then the objective consists of output gap and price inflation. The constraints are this price Phillips curve and dynamic IS curve. We don't have interest rate rule here because central bank is not constrained by it. It can freely set the interest rate. We can reduce this problem a bit so that we drop this IS curve from the maximization. So we have Phillips curve as only constraint in the maximization, and then given path for price inflation and output gap, this IS curve will determine the path for interest rate. And we have it here, so we don't need to maximize over interest rate. We only maximize over price inflation and output gap here. Then we have expectations here in the Phillips curve. And now, whether we assume that there's a discretion or commitment, this matters for how we treat these expectations. So if we assume discretion, we assume that central bank is optimizing sequentially. It doesn't commit to any promises how it behaves, and therefore it cannot influence households' expectations. So it takes expectations as given, and it re-optimizes on each period. Then if we assume that central bank can commit to its policies, it doesn't take expectations given, and it commits to a path of actions conditional on evolution of the economy. So it doesn't commit, it doesn't promise that it will set certain interest rates in the future, but it will say commit that it will respond with known way as the shocks hit the economy. And then central bank is not free to re-optimize on each period. It has to act according to this plan it has promised to follow. But recall, it doesn't restrict the interest rate to be certain values. It only restricts that central bank responds to shocks according to the plan it has so revealed. So when we assume discretion, we simply take derivatives with respect to period t variables, and we obtain these first order conditions here. This first term comes from a utility function, and then we have a multiplier here. This first term comes from utility function, and then this from the constraint. Once we combine these, we will get this condition according to which which will hold actually only when both are 0. And this is because in our flexible weights economy, output and price inflation always move the same direction. If you recall that from impulse responses. So if output gap is positive, then it is always that inflation is positive. So this can hold only when these both are 0. So optimal policy under discretion is to stabilize both output gap and price inflation. So there is sort of a divine coincidence that central bank actually can stabilize both of these variables. In this sticky simple sticky price model, the task of central bank is actually quite easy, since it can stabilize both gaps. And then let's see the commitment solution for commitment. So for t equaling 1, we compute actually the same first order conditions are as discretion. But then for t equaling 1, we will have extra term here, because for t equaling 1, we have this future inflation of last period, which we need to take into account in the maximization. A bit similarly as with household optimization problem, where we had the expectational variables. So on period t, this is a expectational variable on t plus 1, but on period t plus 1, this is the period t plus 1 inflation rate here. So we obtain extra extra term here. There's a typo, this should be minus as well here. All right, for the first period, the condition is the same, but then actually it is that for t equaling 1, this lag multiplier equals 0. Since it equals 0 here, since this is it's 0, so this will give us actually the same solution, that on each period inflation and output gap are 0. So central bank stabilizes both inflation and output gap. So actually this is correct because this term comes from here. So the sign is correct. To make studying of optimal monetary policy a bit more meaningful in this simple model, let's assume sort of a cost push shock to the model. It can be, for example, oil price shock, or we can think is that it is a similar, for example, oil price shock or tax shock, something that makes prices to increase, but also drives the economy away from the efficient economy, so that there is a lower output level and in the efficient economy. So when this is positive, it means that if inflation opens, if inflation is positive, then central bank can only stabilize inflation by having a negative output gap. So there is a trade-off for central bank in between stabilizing inflation and output gap. Discretionary policy is the same as we saw already. So it will allow output gap open when there is inflation opening, and these model parameters then determine the co-movement of these variables. This will be more clear when we look at the graphs. But this is a static problem, so everything that happens in one period, so there is no dynamic, it's just t variables. When we have commitment, this leads to a dynamic condition where current period output is measured against evolution of prices with respect to prices before the shock took place. So as long as the price level hasn't come to its steady state, central bank will allow output gap be open. How this matters is that now there's cost push shock that dies away in same period that it comes, so it lasts only one period. It means that when under discretion, the central bank has to stabilize the economy during the initial period, since it cannot plan its or promise its actions over periods of time. So it has to allow the output gap open a lot in order to stabilize the inflation. But still inflation opens quite a lot. Then under commitment, central bank is not constrained to do everything on the initial period. So it lets the output gap open, but less than in discretionary policy, and then over time returns the output gap to its steady state, to the zero. And as was the commitment condition, this takes place as long as price level is differing from the original value, 0. So central bank under commitment is able to smooth its actions over time, and this will generate smaller welfare costs. Then if we have persistent shock, we see that the difference between these policies is again that under commitment, central bank aims at bringing the price stability back to its original level, whereas under discretion, central bank allows it to grow over time. And then now we see clearly that there is a difference in the link between output cap and inflation. So both have quite same path for output cap, but under commitment, central bank is able to stabilize inflation much quickly than under discretion. So when the households understand central bank's actions, under commitment, central bank can influence so that expectations so that the price level and inflation is stabilized quickly. And it doesn't open the output gap much more than under discretion to reduce aggregate demand and this way stabilize inflation. So in small models, like we have had this in this lecture, this sort of linear quadratic optimization works well, where we have second order approximation and linear constraints. For larger models, this is more difficult to do. And then as a reference, you can see Smith-Grohan and Uribe's work. They have several papers on this. If there's a larger model, so-called medium scale DSC model, where we have also capital accumulation in the model, then what one can do is to maximize household welfare subject to model constraint in the original non-linear version of the model. And this will tell us the optimal policy. If we linearize the model, then we can study the dynamics when central bank is operating under the optimal policy. And then we can further take a second order approximation to all model conditions, to all equations, and then we can study the welfare and do welfare comparisons between optimal policy, for example, and then with simple monetary policy rules. And the same can be done for fiscal policy too.